Assalamu alaikum everyone. Welcome to yet another video of production function. Today we are going to discuss about another important topic, return to scale, and later on we will also solve an interesting mathematical problem about it. So let's start. First of all, let's have an idea of return to scale. So basically it refers to the manner of change in output caused by the increase in all the inputs simultaneously and in the same proportion. So basically it's talk about the manner of change in output if we increase the production factors simultaneously and in the same proportion. Means if we double the production factor, or if we triple it, if we make it 4 times, then what will be the manner of output. So in return to scale, return refers to change in physical output, scale refers to the quantity of input employed, and change in scale means that all factors of production are increased or decreased in the same proportion. So if we consider return to scale have 3 types. The first one is increasing return to scale, then constant return to scale, and decreasing returns to scale. Moving on, if you want to have a bookish knowledge about all these 3 types of return to scale, then you can pause the video and have a look at this, but I will take you through an example and make you understand in a better way. So for example, consider a restaurant. So in a restaurant there is one chef and one kitchen or something. So this restaurant produces 4 burgers or 4 outputs, 4 units of output. So if we double the factors of production, I am not considering only one factor, both the factor will be doubled in the same proportion simultaneously at the same time. In these cases there can be 3 cases of change in output. For example, because it was doubled in input, the output can also become double. Like here are 4 burgers, in the first case we get 4 plus 4, 8 burgers. So in this kinds of scenario, it is called CRS, or constant return to scale, which is this one. Moving on, there can be some cases where because of economies of scale, there can be an increase in the output. For example, here you can see there are 10 units of burger produced. So that refers that because of increment of both the factors, the output increased, but it increased in an increasing rate. So that's why it is called IRS, or increasing return to scale. And the last case we have is the output has increased but not at the level of it has been doubled, or the output become more than double. So it became like 4 to 6. So if you consider double of 4 is 8, so 6 is less than that. So in this kind of scenario, we say that the output has definitely increased because of the changes of input in production function, but the output has increased in a decreasing rate. That's why it is called decreasing return to scale. So I hope that gave you a clear idea of return to scale. Now we will look at our problem set. So this is the problem set of production function, the theory of production chapter. So I will discuss about the last one, the 5.5, which actually deals with return to scale. So let's start. So the question asked to determine the return to scale for each of the following functions. So we have in hand 3 functions. So we will go one by one. Let's solve it. So first of all, we will answer the first question. So the given production function is q is equal to x square plus 6xy plus 7y square. So in the step 1, we will be multiplying these all the factors x and y. The factor are x and y. So we will multiply with a constant, and the constant will be a number that is more than 1, and it will be a number that is same for for x and y. So for example, we consider that new output will be q dash. So in this scenario, the production function will look like this, that kx square plus 6 into kx dot ky plus 7 ky square. So if we go on with our calculation, we'll find out that if we just make the common of k squares, then we will find out that x square plus 6y plus 7y square here is a term that is absolutely similar to our initial production function. So we can replicate it here. So it turns out that k square dot or into q. So k square times q. Here we can go to our second step and we can do some analysis here. So here we got k dash q dash is equal to k square times of q, the initial production function. So the power of k is greater than 1. It is 2, right? So that refers that the output will be double from the initial production function if we increase all the input factors by the same proportion. So in steps 3, now we will take the decision. Considering this, we can say the production function exhibits increasing return to scale. So that's our answer. Moving on to our second question. So first of all, we have our production function q is equal to 3x square upon 5y squared. So again, we will multiply by a constant factor k. The new output we consider q dash. So here you are looking at the new form of production function. So after giving the power to each of the multiples, we get this, and we cut the xkk because it is on the denominator and numerator at the same time, and we found that it actually returning to the initial production function. So actually what is happening, q dash is actually the q, the initial one. So there actually have not been any other change regarding the output. It remained with the same proportion. The ratio remains same. That's why it is coming like 1. Okay. So we can go to, you can also say that k to the power 0 is equal to 1, right? So we can go to our second step and do some analysis. So here we got k's power is 0. So that means that the output will be constant as of the initial production function output if we increase all the input factors by the same proportion. In this kind of scenario, we have already discussed about this kind of scenario. This production function actually, I beg your pardon, there was some copy paste mistake. There will be the production function here. So this production function refers constant return to scale. So the next and the final one, we'll solve the 5.5c. So again, the step 1, this is bit interesting. So we have this function 10 into L to the power 0.6 k to the power 0.2. So we will, now we have k in here. Okay, so in that scenario we consider another constant c. So the new output is q dash, and we found by multiplying with c with each of the multiples, we get, and we also divide the power among them, and then we know that if the powers of similar base multiple gets added, so we add them, and then it turns out that the new production function is c to the power 0.8 into 10 into L to the power 0.6 k to the power 0.2. So if you are closely looking, then this portion is absolutely similar to this production function. So we can say the c to the power 0.8 into q. So in step 2, if we do some analysis, we got c to the power 0.8. So 0.8 is definitely less than 1. So q will be multiplied by something which will be definitely less than 1. So if you are multiplying something with a power of less than 1, that means the increase will be done, increase will happen less than what is the proportionate increment, like it will be less than that. Okay, so the output will increase from the initial production function, but it will be less than the double as we increase all the input factor by the same proportion. So at the bottom line is this production function is actually exhibiting decreasing return to scale. So this video assignment was submitted to Professor Dr. Muhammad Sadiqunnobby Choudhury sir, who is a professor of Department of Economics, School of Social Sciences, Shahjalal University of Science and Technology, Sylhet. And I am here with you throughout the video, Muhammad Taslimul Haq, a sophomore business administration student from Shahjalal University of Science and Technology. And as well as thanks for watching the video. If you like this video, please consider subscribing my channel, and that's it.